Hello, my name is Annika Anderson. I'm a student of Renewable Energy Engineering at Oregon Institute of Technology. In today's chemistry presentation, we're going to take a look at the rapid decomposition of hydrogen peroxide. H2O2 is the molecular formula for something that many of us have in our bathroom cabinets and is commonly used as a first aid antiseptic. Hydrogen peroxide, when it decomposes, turns into liquid water and oxygen gas, which we can see in this reaction right here. The problem with this is that it naturally occurs very, very slowly, and so it's not something that we would be able to see in this presentation. So today we're going to be using a catalyst, and so for demonstration I've written out the chemical equations for what would happen with the use of a catalyst. In these equations we've used potassium iodide, which of course ionically bonded when put into water breaks down into the potassium cation and the iodide anion. The cation does not participate in this reaction, but the anion does, which we can see through these chemical reactions here. To simplify things, you can see that we start out with hydrogen peroxide on the far left and our anion, and at the end we finish with liquid water, oxygen gas, and our very same anion. So the thought with using a catalyst is that it lowers the energy that is required to start a reaction, and so it helps to speed up that reaction, but itself is not used up in the reaction, which we can see by its presence here again at the end of the reaction. So for today's presentation, our catalyst is yeast, which we saw in lab just a couple weeks ago. Here, one last note about this reaction is that it's exothermic, and so it's putting off heat, approximately 98 kilojoules per mole of hydrogen peroxide. Alright, so I think we're ready to do this. Goggles on, shall we? Alright, here in the bottle we have hydrogen peroxide, 3%, which is really common at drugstores. You can easily find that. 3% obviously not very concentrated, and so this is a pretty mild reaction. We would see a much more exciting reaction if we use something like 30% concentration. But this is 3%, and then also in the solution we have liquid dish soap, which does not affect the reaction. It simply helps to trap the oxygen gas at the end into little bubbles so that we can actually see it. And then we also have food coloring, just for fun. Alright, so here we have it. Here's our yeast solution, and here we go. Alright, so we can see this lovely fountain of pink bubbles, and the reaction is still running. But here we have it. So thanks for watching.